Hi everyone. This video is going to demonstrate how to solve question 6 from the QCAA Sample IA2 exam. It's a tech active question. So we're looking at the line y equals mx, which is a straight line passing through the origin. There's no value for intercept. It divides the area under this curve into two regions of equal area. Now the first thing I'm going to do is graph the curve on my calculator to get a look at what I'm dealing with. So I'll use the graphing app, and I've entered the value, the formula for the curve, and it's a lovely parabola, and it says the domain is from 0 to 2, so we're really only interested in this section here of the curve. Now we do have a straight line y equals mx, but we don't know m. Let's say that m was, I don't know, just say 0.5, just for, it probably isn't that, but we'll just get an idea of what that's going to do. And so you can see that my straight line here will hit the origin and continue and split this parabola into two sections. That's what they're talking about. So time to do a little bit of a sketch on my response booklet. So there's the y-axis, there's the x-axis, there's my parabola from 0 to 2, and here comes my straight line. So my straight line is going to go through here. That's the formula y equals mx, and the other one was the formula y equaled 2x multiplied by 2 take x. Now importantly, I need to know that intersection point, and I don't know that, but I can give that. I won't call it x because x obviously means the x-axis, so I'll just give it the value a, and we'll figure that out as we go. The area here must be half of the total area under the parabola, because that other unshaded part has to be equal. So I suppose the very first thing to do is find the total area that we're dealing with. The total area we're dealing with would be the integral from 0 to 2 of the parabola. Now we have the formula for that, dx. We could do this using calculus and algebra, or let me just turn that one off for a minute. So I'm just focusing on this. I could do the integral using technology, and I'll lower limit 0, upper limit 2, and there is my area, 2.6 recurring, 2 2/3. So that's what I'll do. Area is 2 2/3 units squared, and this is using technology. So I'll say by use of, it was a CG50 calculator. I did a G solve, that was the function, and then I did an integral. Now the area that I'm interested in, the shaded area, would be half of that amount. So that's something to keep in mind in the future. That half of that would be 1 1/3. Now let's focus on finding this intersection point. At that intersection point, the y coordinate of these two is equal. Now that's my clue. So I will say the formula here, 2x times 2 minus x, that's the y value of the parabola, equals the y value of the straight line, that's m multiplied by x. Now I think the x value is a, so I'll write 2 times a, 2 minus a, equals m multiplied by a. Expanding out, I'll have 4 times a minus 2 times a squared equals m times a, and then dividing by a, I would have 4 minus 2a equals m. Yeah, that's good. I now have I'm not going to get an answer as a number, but I now have a relationship between the intersection coordinate A and the gradient M. As the gradient changes, then the intersection point changes. Now let's focus on finding the area that's shaded there by using an integral with a difference between curves. I'll probably have to come back and use that idea soon. So the integral between 0 and A, and the parabola is the top one, so that's first. So that's 2x outside 2 take x, and the straight line was the lower one, so that's m times x, and we're integrating with respect to x, and that shaded area was half of the 2 2/3, so that would be 1 1/3 as the answer. So the problem I have here is that I have letter A as a limit and I have letter M, but I can fix that. You see, letter M is the same as 4 minus 2a. So let's keep going. Integral from 0 to a. I might expand this out while I'm going. That's going to be, sorry, that's a mistake. That's going to be 2x times 2 is 4x, and then 2x times this is minus 2x squared minus, now instead of m, I'm going to write 4 minus 2a, then times x dx equals, and I'll put this as 4 over 3. So let's keep simplifying. 4x minus 2x squared. So minus, if I multiply the x through like this, and then it's minus each of those bits. So it's minus 4x minus a negative is plus 2 times a times x, still dx equals 4 over 3. Now I notice that 4x subtract 4x conveniently disappears, so I'll take my integral now. I would have negative 2, x would become cubed, and I would divide by 3. Then for this next part, it would be plus 2 times a is a constant, x would have the power 2, and I divide by the new power, and my limits of integration are a and 0, and that all equals 4 over 3. Good. Let's substitute. So I have negative 2a cubed over 3 plus the 2 times a, which is already there, times a squared, where a substitutes for x, over 2, subtract, and if I substitute 0 for x, that first part is 0, and if I substitute 0 in there, that's also 0, so that's going to disappear nicely. Now let's see what I've got here. It looks like I need a common denominator before I can add those fractions, and the common denominator would be 6. So if I double that one, that would have to be minus 4a cubed plus, now if I want that to be a denominator 6, well, the a times the a squared is a cubed, and if that's 3 times more, then that should be 3 times more. That should be 6a cubed equals 4 over 3. So 6a cubed minus 4a cubed is 2a cubed over 6 equals 4 over 3. I notice that 2 cancels into itself once, cancels into this 3 times. So 1 times a cubed is just a cubed. 3 times 4 over 3, well, the 3's cancel. So the value of a is the cube root of 4. Good. Now the question wanted us to determine the line y equals m times x. So I'll have to come back to this one to find the value of m. So m is 4 minus 2 times a, and down the bottom I know a. So I'll just come back to here. I'll restate that previous m was 4 minus 2 times a minus 2 times the cube root of 4. Therefore, my line y equals m times x is all of this, 4 minus 2 times the cube root of 4 times x. That's the equation of my line. That should cut that area into 2 equal parts. Now, pretty much we finished the question. It did say to evaluate the reasonableness of your solution. Now, tech active, this is where we're going to use our tech to do this. So I'll go back into my equation. Now, yes, I only guessed that to start with. It's nowhere near correct. I think this is going to have to be 4 subtract 2 times the cube root of 4. And that should give me a straight line. I might just zoom in slightly. That's looking a little bit, there we go, that's easier to see. Now I'll use my tech with gsolve, then I'll do an integral, and it'll be the intersection here, the intersection. So it suggests to me for this as a lower bound, I'll accept that suggestion, and then I'll press to the right arrow and it jumps to the next intersection, which is, we never knew the value of a, but that's there, and it does this, and it tells me the area is 1 1/3, exactly the way we thought it would. So we have verified. Okay, that's a pretty long video. Thanks for sticking with me all the way through. Something just happened, all my working disappeared. Oh well, that's okay. See you next time.